This section is a very short section, and you probably won't find it in most books. I've added it because it is of great importance and a very important observation to make on the nature of people and of life versus the inanimate aspects that we normally talk about in physics. I want to talk about the logarithmic nature of the responses to stimulation. And we have seen that demonstrated here because it turns out when we looked at the loudness that we hear, the loudness that we hear is measured in decibels. It's given by beta, and beta is 10 times the log of the intensity of a sound divided by the threshold intensity. Now, I want to go back and talk about this in a little bit of detail. Here we have the intensity. This is the physically measured determination of how loud the sound is. It's the intensity, watts per square meter. This is what we hear. We hear the logarithm of that. It turns out that our bodies take the logarithms of the physical stimulations that are there. This is true for loudness, for sound. It's true for the intensity of light that we see with our eye. It's true of the frequencies that we hear. And let me stop and talk about that just a little bit. If we look at the piano scale, we will learn shortly that this piano scale consists of a set of frequencies. And this set of frequencies, as we go up, we'll find out in the next chapter, these frequencies increase with each one of these being proportional to the one before it. Therefore, it turns out that the frequencies that go up, each half step is a multiple of the one before it, so it's a logarithmic scale. So all of the frequencies are a logarithmic scale. In other words, the frequencies that we hear in music are the logarithms of the actual frequencies. The notes are. This is also true of touch. As we touch something, if we touch something and pick it up that weighs twice as much, we don't really feel twice the pressure. We feel the logarithm of that pressure. That allows our fingers, I'll draw a finger here, allows our fingers to feel something that's just the slightest little feather touching our finger. And at the same time, that finger can put enormous pressure on something like a concrete block or a piece of wood. And our touch is therefore likewise something that takes the logarithm of the actual force or pressure that's put on our fingers or on our bodies. So we experience, and that's the thing I wanted to emphasize in this chapter, this section here, we experience as a human body, both with sound intensity, frequency, light intensity, and also heat and pressure and other stimulations, the logarithm of the stimulation. This allows the person to have a vast range of sensing without overloading the sensing in high values, and to be extremely sensitive to low values. For example, a snake moving in the grass can be heard, but at the same time an explosion doesn't deafen us. I've given the example of the sound intensities already. And it turns out, and we'll discuss this later on in the course, that information is measured mathematically in terms of the logarithm of the probability. Now, if that's true, then we can imagine, it is true, and we can imagine by virtue of that, that if we take the logarithm of the physical data, we're somehow or another extracting the maximum amount of information for our bodies, for our minds to understand. So I suggest to you that life forms take the sensory log to automatically measure the maximum amount of information that we can bring in through our senses. So our senses are not linear in terms of the effects that are logarithmic. That finishes this section, chapter 14, Mechanical Waves and Sound. We're now going to apply this in the next section to music and acoustics.